Let's discuss a question from machine design. So you have a semi-conical clutch, something like this, and you want to, one side of the assembly engine, the gear you want to connect. Okay, the engine shaft you want to connect to the output shaft by means of this clutch. So the mean diameter, though I have drawn it in an exaggerated way, but it will not be this much. Okay, the conical angle is given as alpha. Okay, that is 12.5. So this is 12.5. It's more or less it's a very small cone taper. Okay, 12.5, and the mean diameter is given as 80 mm. So the mean radius would be 40 mm. The mean. Okay, now the torque that can be transferred with this is mu WR cosecant alpha. The cosecant alpha comes because of the taper. Okay, so this is the mean torque that can be, nominal torque that can be transferred. So let's first get this torque, and W is the axial load. Okay, it's the clutch. The idea behind the clutch is that the friction is very important. Okay, so in fact most of the time you have an additional layer of high friction coefficient material on the clutch so that the gripping will be easy. Okay, and that takes place under the action of normal force, which is your W. So 0.32 into W, which is 200, into radius, which is 40 mm. Okay, and into cosecant alpha, which is 12.5. By sin alpha, we have written cosecant alpha. So this is mm. So if I convert and divide by 1000, I'll get in Newton meter. So 11.82 Newton meter is the torque. Now this torque will be obtained, but so obviously this the assembly which you get connected is in this format, and so the net torque that is acting on this assembly because of this, when you add this W and this surface gets grip over to the assembly, the torque that acts on the assembly is 11.82 Newton meter. So this torque, because it's a mechanical component, it will take some time to get to the proper speed. Okay, basically you are connecting I think the time required. Okay, the clutch is used to connect the electric motor with the stationary flywheel. So this is your flywheel side. Okay, and on the right side you have the motor. So motor, when you connect to the flywheel, so flywheel, the torque that is acting by this torque acting on the flywheel because of the clutch is 11.82. But flywheel will take some time because it is starting from 0. It will take some time to come to the motor speed. Ultimately both will be running at the same speed. It will take some time. How much is that time? Knowing, you know the torque. So the torque acting on a body which is free to rotate about an axis is I alpha. So, and alpha, we know that is rate of change of angular velocity. Now initially it is 0 and torque is constant, I is constant, so alpha is constant. So I can write d omega is final omega minus initial omega, which is 0, by time t. Okay, and what is asked is time t. So alpha is omega by t. So torque is equal to I omega by t. Remember, this happens only when alpha is constant, and alpha is constant because t and I is constant. So time will be your torque, which is 11.82, and your I is given as 0.4 kg mm meter square. Okay, and so this is time. This is 2 pi. The speed omega will be your 2 pi n by 60. Okay, omega is 2 pi n by 60. And so what we do is n is, it has to obtain the motor speed, which is 900 by 60. So everything you know except the time. So time will be 0.4 into 2 pi into 900 by 60 into the torque value, which is 11.82. So when you solve this, you get about 3.1877 seconds. So that is close to 3.2 seconds. Okay, so the answer for this will be 3.2 seconds. Okay, so this is just a purely mechanics problem, but only thing is that you got to remember this formula. Remember, the torque is always in terms of mu WR, but because of this conical you get this term cosecant alpha. Thank you.